Okay, this one should be shared with you now. It's showing the title for the experiment, right? Experiment 6, some organic reaction. Yes, okay, perfect, perfect. So we are in the right place. Okay, for this experiment today, we have two parts of the experiment. One is esterification, and with the esterification, we have carboxylic acid and alcohol. With carboxylic acid and alcohol, the product is going to be ester. The functional group for ester is a COO. So it's like C double bond oxygen, C single bond oxygen, and then we have two groups attached to one on each side to the carbon. So we have ester functional group. Esters are fruity flavor. They have the fruit flavor. They have fruity flavor, and they are used as an additive for food products. Sometimes for those body mists, they can with esters, because if they use perfume, it's going to be a lot more expensive. So it depends on the size of the carboxylic acid. So on the left side of this reaction, you have two reactants. You have acetic acid and ethyl alcohol. Now, if instead of using acetic acid, if I use like benzoic acid with methanol, I would get a different size of ester, and the flavor or the smell or sense of that is going to change. Right now, this one, when we get acetic acid with ethyl alcohol, the product, it would smell like banana. But if we change it to benzoic acid and methanol, it would change like oil of wintergreen, like spearmint. So it's going to be different flavored if you change the size. If you search it up, you will find that you can get with the salicylic acid and methyl alcohol, you would get the oil of methyl salicylate is going to be synthesized. So it's going to give you different, different smell of the flavor. Different flavor would be produced. So it depends on the size of the acid, depends on the size of the alcohol. The second part of the experiment is reactions of organic compounds. One part of this organic reactions is the reactions that would recognize the functional group. I don't know if the lecture has covered functional groups already or not, but one of the functional groups that it's like formaldehyde functional group. When you have carbonyl group with the R group is representative group of alkyl or carbon, and then you have hydrogen on the other side. This is for formaldehyde, is the first member of the aldehyde functional groups. Then you have ethanol. This is also aldehyde. A CO double bond with one hydrogen and then one carbon attached. Here you have two hydrogens attached is formaldehyde. When you have one carbon or two carbon aldehyde is going to be I'm sorry, let me answer the phone for Professor Larry, and I Okay, I am sorry. I had to talk to Professor Larry. He was waiting for my call, and I didn't call him. So I was just helping, just a phone call. That's why I had to put on mute so you don't hear me. 2 minutes. I'm sorry. Back to the aldehyde functional group. So we have the 2-carbon aldehyde, we have 3-carbon aldehyde, but what we are going to, I'm not teaching you all the organic chemistry in this lab. I'm just trying to help you how experimentally we are going to determine if we have an unknown, is it going to be aldehyde, is it going to be ketone, or is going to be water, none of those, or is going to be like methyl ketone. So we have like 4 choices. We have 4 unknown and 4 choices. One of the choices is going to be water, one would be aldehyde, one would be ketone, and one would be methyl ketone specifically. How do we know we have aldehyde? If we mix the aldehyde, that's end of page 2. If we mix the aldehyde with a reagent, it's called toluene reagent. With the toluene reagent, which right here we have the toluene reagent with the toluene test, is going to leave like silver mirror inside the tube, the test tube. So if our unknown gives silver mirror with toluene reagent, is going to be aldehyde. So that is a positive test for aldehyde. If it doesn't give a silver mirror, that means that is not aldehyde. So we are looking for evidence for a reaction. With the evidence with the reaction, so if the toluene test or toluene reagent, if it makes the unknown to give you silver mirror, basically silver is going to precipitate around the bottom of the test tube, then is a confirmation that you have aldehyde as functional group. So in organic molecule, based on the functional group, that compound belongs to a different family. So we have ketone here. The difference between ketone and aldehyde is that for ketone, you have 2 carbon attached to CO double bond. You see the CO double bond is common for both of them, for aldehyde and for ketone. For aldehyde, one side is carbon, the other side is hydrogen. For ketone, you get both sides carbon. So ketone does not react with toluene reagent. Aldehyde does. If your ketone is a methyl ketone, if the ketone is a methyl ketone, then what does it mean, methyl ketone? Again, if the organic chapter has been, or nomenclature has been covered in your lecture, you already know that a CH3 group is a methyl, and this R group on 2 sides of the carbonyl for ketone doesn't have to be always CH3. So it could be CH3, it could be CH3, CH2, it could be ethyl group, it could be propyl group, it could be any size of the carbon chain. But if the size of the carbon chain is just 1 carbon, then we have a methyl ketone. So this is going to be this is a methyl ketone. How do we know a compound is methyl ketone? So you take a unknown, it's clear, colorless solution. So it looks like water. How do you know that is a methyl ketone, or that is aldehyde, or that is water? So one of the indication for methyl ketone is that if you mix it with the iodine solution, is going to give you a yellow color precipitate. So that yellow color precipitate that is forming is going to indicate that your compound is going to be with a yellow precipitate or bright yellow precipitate, indicates that you have methyl ketone. Now, what is DNP? DNPH? DNPH is the dinitrophenylhydrazine, is another reagent. Even if you were in the lab, I wouldn't expect you to know the structure formula for this compound, as long as you know that if you have a 2,4-DNPH is a compound or is a reagent, that this reagent is going to that this reagent is going to give yellow precipitate, either like a yellow to red color range. Precipitate often is like either yellow color or orange color. Precipitate that is going to, is an indication your compound is either aldehyde or is ketone. So you get that part? It's either aldehyde or is ketone. So we know that if it's either aldehyde or ketone, then we do toluene test. If it's positive, then we know is aldehyde. Now, if it's not, if it doesn't give toluene test, positive test, or it doesn't give silver mirror, then we know that is not aldehyde, so it must be ketone. If it doesn't give precipitate, then what it means? It means that your unknown is water. So it's not aldehyde, it's not ketone. If it gives you positive test with toluene, it's going to be aldehyde. If it's negative, then we know it's ketone. Now, if it's ketone, is it going to be methyl ketone or not methyl ketone? Then we have to do the iodoform test, which we are adding the iodine solution. And with the iodine solution, if it gives yellow color precipitate, then we know that we have a methyl ketone. So we have 4 different possible unknown. The unknown could be one of the 4 compounds. It could be water. It could be aldehyde. It could be methyl ketone or non-methyl ketone. The toluene reagent needs to be disposed right away, because if you don't dispose it right away, it becomes, if it dries up, it becomes like explosive compound, and that's why it needs to be cleaned up right after the experiment. We usually clean it up with acid to make sure that is clear. It doesn't stay and it dries up as the toluene reagent or leftover of the toluene reaction. So when it comes to procedure, we are going to do 2 parts experiment. One is esterification, and the second part is test for aldehydes and ketones. When we have test for aldehydes and ketones, we have 4 unknowns. We are going to follow the procedure. First, we do the DNPH test. Then we are going to do iodoform test. If it's negative DNP, if it's negative, then it's water. So if it's negative with iodoform, that means it's not a methyl ketone. If it's positive with toluene, it means that is aldehyde. And the one that did not give positive test with aldehyde, with toluene and iodoform, that is going to be a non-methyl ketone. So you are going to use like a plus sign, a negative sign when you do test here. And the test tube that is negative for each of these steps, then you don't continue with that. So for first set of the experiment, you have 4 test tubes, then you have 3, then you have 2. Because when you mark negative, that means there was a negative test and you don't have to continue with that experiment. Then based on the information that you get from, if it's positive, for example, for toluene is going to be aldehyde, you are going to fill this part of the worksheet. And if it's negative with the DNP, that means is water. And that's how you fill out your lab report or the worksheet for the experiment. Okay, I am going to start with the first experiment, which is esterification. And at least with the esterification, we don't have to go through the problems that we had for the other lab. I want you to please keep the procedure open, because I'm going to go back to the collaborate and make sure that you see the video of the actual experiment. So I won't be able to keep both pages on, and I would depend on your procedure. So I will ask you to give me the procedure, steps of the procedure. So please keep your procedure page open. Do not leave only data sheet open. you should actually leave the procedure page open, perform the experiment, and as like you end up with like a result of the experiment, you record that in your data sheet. Okay. We are doing experiment 6 today, right? Okay, perfect. Perfect. I'm going to start with the esterification. Now, I'm going to stop sharing this document with you and go to the video now. Okay, we're going to start the first experiment first. First part of the experiment first. So, with the first part of the experiment, ester. I'm going to start hot water bath. So I need the hot water for the experiment. So could you tell me what I need next? What do I need? In preparation of the ester, so esterification. What do I need next? I need to set up the hot water bath. I already did that. So I have the hot water bath here already prepared and it's going. Next step. 0.5 gram of salicylic acid. So I'm taking the salicylic acid and measuring 0.5 grams of it. I measure the 0.5 grams on weighing paper, and I'm going to make a funnel and transfer salicylic acid into the test tube. Add 3 milliliters of methanol. We do need a catalyst for this reaction. It doesn't happen on its own. We do need a catalyst. What is the catalyst that we are using here? 8 drops of sulfuric acid, and the drops of sulfuric acids are used as catalyst for the reaction. Catalyst for reaction is it's added to the reactant that is going to increase the rate of the reaction or make the reaction happen faster. The sulfuric acid is inside the fume hood, so I'm going to take the test tube to the fume hood, use my gloves, and add the 8 drops, and I'll be right back. I added the 8 drops of the sulfuric acid, and I'm going to place in hot water for 10 minutes. Very good. Thank you for your help. I'm going to stay in the hot water for 10 minutes and start the timing at this point. Okay. And we can move to the second part of the experiment. Okay. I'm going to take 4 test tubes, and they are labeled A, B, C, and D. I'm going to take the rest of the test tubes out. So I know I'm working with 4 test tubes at the time. And they are labeled A, B, C, and D. We are going to, what is my next step? 5 drops of each of the unknown. And what else? And we want to add 20 drops of the reagent. Okay. So let's go to fume hood. Just hope that when I come back, I remember 5 drops of each and 20 drops of 20 drops of the reagent. Okay. Adding 3, 4, 5 drops of A to test tube A. 5 drops of B to test tube B, and so on. B to C. 5 drops. Same thing for D. Now we should be able to eliminate one of these unknowns at this step as water, because if it doesn't react with the reagent of 2,4-dinitro, phenylhydrazine is going to be water. If it's aldehyde or ketone, it will react with the reagent. So I am showing you the reagent first before adding. You can take a screenshot of this. I have the unknown A in the test tube, and this is a clear, is orange color, but it is clear solution. So the evidence for the reaction to make sure that this is water or is not water is formation of a precipitate. If precipitate forms, that means the compound is either aldehyde or ketone. If it doesn't form, there is water. And we did the hot water bath. If it doesn't react, then we, if 2 or 3 of them don't react, then we use hot water. If one doesn't react, we know that one of the unknown is water at this point. That was A, yes. So if for A, you are going to put plus or positive. That means the reaction actually took place. B, okay. I have a problem with my dropper is contaminated. So I'm going to have to change the dropper because I'm afraid that that's not going to give me the right result. Okay, this was the contaminated solution, I think. I'm going to have to repeat it for B because my dropper was contaminated. I want to make sure that is the right result. Okay, going to add to C without touching the test tube and D. Okay, test tube C and tube D. So it would be positive for A, positive for this. It's positive for A, positive for C, and positive for D. B would be negative. B as a boy would be negative. It was just a little contamination that I had there. So B is negative. Okay? B is negative. A, C, and D is positive. Okay. We are going to move to the next step. Yes, all of them goes with the 2,4-dinitro. Yes. So I'm going to change the test tubes and start with the new. Start with the new unknowns. New set. Next experiment, next part of the experiment. What's next? Test for with iodoform test, okay? With the iodoform test, for each of the unknown, we are going to add 5 drops again, right? 5 drops of the unknown A. Which unknown should I use? I'm going to use A, C, and D, right? A, C, and D only. 5 drops of A. Five drops of A, 5 drops C, and 5 drops of D. And next step, we are going to add the 2 milliliters of dioxane to each. Okay. 2 milliliters dioxane to each one. Okay. Adding 2 milliliters of dioxane to each one. Then we are going to add, oh, you're moving faster than me. Okay. Then we are going to add 2 milliliters of water to each. Okay. Each time, like 1 full dropper is approximately 1 milliliter. For qualitative analysis, it's okay. When it's quantitative, when you are doing like titration or a sensitive measurement, we have to use accurate measurement. But this is like every 20 drops, it counts as 1 milliliter or 1 full dropper. With this dropper that I'm using, each time I squeeze it like fully, it takes 1 milliliter approximately. And next, we are adding 10 drops of sodium hydroxide to each. Ten, 3, 4, 5, 6, 7, 9, 10. Do you see the setup down here? I hope. Okay. After sodium hydroxide, what should I add? After sodium hydroxide, going to add the iodine reagent with the iodine solution, 10 drops, and look for yellow color precipitate. If yellow color precipitate appears, I'm going to stop, but either the color has to stay yellow or a yellow precipitate should form. And only one of these three is going to form the yellow color precipitate. So I'm going to add the 10 drops. Mix it well. If yellow color precipitate appears, that means that is the methyl ketone. If not, we can actually have to repeat this. It says to repeat this up to like 60 drops. But as soon as I see them yellow color precipitate, I'm not going to continue, because the key is not how much of the reagent I add, is to see the yellow color precipitate. Okay. It's yellow color, but I don't see the precipitate yet, so it has to form a solid. It should turn cloudy. Okay. Do you see this test tube? That's for the iodoform test. It turned cloudy. Is it clear that it's cloudy? Yes? Okay. You can take a screenshot of this. This is the proof for iodoform, and that was unknown C. Okay. That's the unknown C. Positive. For C is positive, A and D are negative. A and D are negative because it didn't turn cloudy. Okay. C is positive. Wasn't that C that was positive? Was it B or C? Which one was negative with the first one? Negative with the... Please don't get mixed up. Okay. The first one, B was negative when I added the DNP, right? Okay, B was negative. So B was negative for the first test for DNP. The 2,4-dinitro-DNP, B was negative. For these two, for the last, for iodoform, A was negative, D was negative, but C was positive. And the positive C, it's this. This is the positive C because we have a cloudy solution here. That means a precipitate has formed. That's C. That is positive. Okay, the precipitate that forms here. Bright yellow, yes, it is a yellow color here. It is a yellow color here. Maybe you could see better with the black background. It's yellow color. Okay, with the black background, if it shows, or when I add the drops, you see that it's turning more cloudy. See, the precipitate is forming when I'm adding this. So that was the C. Okay, good. Did you see it? Okay, perfect. Perfect. Okay, so down to 2. So for the last one, we have to do the Toluene reagent and to find out if the we want to put the we have to make the Toluene reagent first. Okay, so we have to make the Toluene reagent. Then what concentration is it? 10%. Toluene reagent first. So in a test tube, I'm going to make a Toluene reagent, and then I'm going to divide in two test tubes. Okay? So first step, 1 milliliter of silver nitrate. And 1 milliliter of silver nitrate is 20 drops. Okay. I'm going to use 2 milliliters of silver nitrate because I want to divide it. I want to put it in each one separately. Okay. I have my silver nitrate, and we are adding sodium hydroxide. When I add sodium hydroxide to the silver nitrate, it's going to turn black color. It's going to form a precipitate. Okay. It's forming silver oxide or silver hydroxide, rather, silver hydroxide, and is a dark brown color. Now, when I have this, I hope the recorder did not record that part. So, when I have the black precipitate, now I have to add ammonium hydroxide, the 6 molar ammonium hydroxide, until it's completely dissolved. Okay, so I'm going to finish this part first before I show you the ester. So I'm going to have to add enough. I have to add and shake until it dissolves. It has to turn clear again. Okay, so I'm going to, the 3 steps, the first 3 steps that I'm performing here is just to make the toluene reagent. I'm testing for A and D only, yes. Okay, so now it turned clear after adding ammonium hydroxide. It turned clear because in basic solution, ammonia is basic. When I add ammonium hydroxide, it makes the solution basic. So silver becomes soluble, and because it's soluble, then we get clear solution again. So I have my toluene reagent ready. Okay, so from the toluene reagent is going to be used for compound A and D. So I have my toluene reagent here, and I'm going to add some acid to test tube so it doesn't dry. And I'm going to add unknown A to the first test tube. Unknown D to second test tube. And we have to wait. One of them is going to form a dark black precipitate, or is going to form a mirror. It looks like this is the one, but I'm waiting for that mirror to form so you have an evidence for the reaction. Even the dark precipitate still is the answer, but this one, nothing formed here. D, yes. Unknown D is the one with the black precipitate, which is the positive test for toluene. We have the answer already, but I just want to make sure that I can get some of that silver forming. Going to leave it alone. And sometimes we have to heat it up. A would be ketone, yes. A would be ketone, and D would be. Okay, I placed it in hot water, so you could actually see that silver mirror. Hopefully, you would see the silver mirror. So D was the aldehyde, right? A was negative and D was positive. B, you just put for B, for iodoform test, you just put either blank or you put Na, not applicable, because we didn't test B with iodoform. So you just put Na for that, or just cross. If you read the procedure somewhere, it should say either you put like cross sign, or you just put, just make sure you don't put a positive. Yes. Okay. Okay, that's part D of the experiment. Just going to go back to part A. For part A of the experiment, it tells you to, after the 10 minutes heat, we are supposed to add it to hot water. So I'm going to put some hot water in a small beaker. And we place the ester that we had it on the heat for the 10 minutes. It says to pour it into the hot water. And fan it toward your nose so you could test for odor. And I guess you have no choice at this point, but believe me that it actually smells like spearmint and is like the oil of wintergreen. So it's the same flavor as those strong chewing gums with the spearmint flavor. So that's confirmation that the ester was, yes, the ester was formed. Yes. Any questions? Okay. I really wanted to show you the silver that is forming here, the silver mirror, and that's why I left it in the hot water. I hope you can see the top portion of this test tube now. Do you see any shiny part of the test tube to believe that is the silver mirror? Yes? No? Well, I see it here. I see the silver mirror here. It's not like clear mirror, but if you look at the appearance of the glass down here compared to up here, you see that it's different and it's shiny. You could take a screenshot of this also. Yeah, I can hold that black towel. Maybe it's more clear for you, so there is no light. Okay. Did you see that? Did you take a screenshot of this? Please take a screenshot of the unknown D with the silver mirror. It does? Okay, good. Good, at least it does help. Perfect. Yeah, this one did not react and stayed like a gray. Okay. We have the data for the experiment, and we did talk about the theory for esterification and for the reactions of aldehydes and ketones, some of the reactions. So it's not that we covered the whole chapter of aldehydes and ketones, but at least it can help you to understand that organic chemicals, they are different from each other, different family, they are different from each other by the different functional group. Like aldehyde is a CO double bond attached to one side carbon, one side hydrogen, but ketone is a CO double bond attached to carbon on both sides. And as a result, they have different type of chemical reactions. These chemical reactions, they are known as like classification reaction, which we can use this type of reactions in order to classify our compound to be aldehyde, to be ketone, or to be methyl ketone. So that's the difference. That is the idea, to have an idea that how do they know if you have an unknown, is it aldehyde or ketone? So if they have a way to find out if something is aldehyde or ketone, sure, there is another reagent that can tell you your compound is alcohol functional group or is not alcohol. So if you have like ceric nitrate reagent, that would show like a specific color with alcohol only and no color with the aldehyde or ketone, then you can say definitely you have alcohol. So every molecule, every class or every family of the molecule is going to be is going to be specific, like it would have a specific type of chemical reactions. And based on the chemical reactions of unknown, based on the result of the chemical reaction of unknown, we could say if the compound is belongs to that family or it doesn't belong to the family. Okay. Questions? Any questions for me? If you don't have the answer, I think you have to watch the video entirely and then you find answers, right? Yes, for the conclusion part, name of the unknown. That basically is the family of the unknown. Does it belong to aldehyde? Because you don't know the name for it, but you know that based on the reactions, is it going to belong to aldehyde, ketone, or methyl ketone family? And if it's none of those, it's going to be water. pH, that's a D and pH, that's just phenylhydrazine. So it's the name of the reagent, so you don't have to actually worry about the structure. Yes, it's a D and pH reagent. Very good. Any other questions you might have for the experiment? If you don't have any questions for the experiment, I'm going to stop the recording and I'm going to call for attendance, and we are going to continue with discussions with your questions and answers for the day. But I'm going to stop the recording to call for attendance at this point. Then we can work on the worksheet, or you could ask your questions. Or if you missed the experiment, I think it's better for you to go back and watch the video so you have better understanding of if it was like positive, how did it look like for methyl ketone or not. Because it's better to have the evidence, just the answer to that part of the work.